Earlier, we created these values. First, we had delete, then insert, then our traverses. Just to keep them in order, I'm going to take these traverses and move them under our insert. That way we can just code them in order. So first thing that we're going to want to do is make our delete. Before we do that though, we do need to make some private variables. We are going to have a private node head. And what this is doing is it is going to grab the head of our doubly linked list. With our head, we are also going to have a tail. So we're going to make a private node, and we will call this tail. Both of these are going to be pointers to our head and tail nodes. So this head and this tail node right here. In our delete, we've passed in the name that we wish to delete. We are going to have to go through our linked list first to see if our name is even in our linked list. If it's not, we are just going to break out of this method. If it's not, we're just going to break out of this method. And if it's not in here, we're just going to break out of our method and return. However, if it is in here, we are then going to have to go through our list again and insert it. And we're going to have to do a special technique to make sure we reconnect the nodes correctly and carefully. First thing that we want to do, as I said, is iterate through our doubly linked list to see if it's even in here. So this is going to be kind of a check. We are going to have for. We are going to make a new node, current, and we're going to set it equal to head. That way it'll grab our entire doubly linked list. And we are going to run this as long as current does not equal null. And then we're just going to do current is equal to current dot get next. And that way we will continuously increment through our doubly linked list. Inside of here, we're going to have an if statement because we need to see if our name is even in here. So we will have if, and then we're going to have name dot, and then we have all these string methods that we can use. So what I'm going to do is use name dot compare, and we're going to use compare to, and we're going to ignore the case. And so we'll just use name dot compare to ignore case. And then what we are going to pass in here is our current value. So we're going to do current dot get data, and that will give us our current data. And then we can go inside of this if statement. However, we see that there's a red line under here. And that's because we have not used the compare to ignore case correctly. To use compare to correctly, if we hover over this, we can see the actual definition of this. And this is the part that's important right here, the return. If our argument string is equal to the string, so the argument I think is inside of the parentheses, and it's equal to name, we are going to return a 0. Next, if the string is less than our string argument, we are going to return some negative number. So that means if the name is less than our current.getData, we're going to have some negative value. Now, if our name is greater than our argument right here, if our argument is less than the name, we are going to return some positive number. And we want to see if this is equal to each other. So we're just going to use where it's equal to 0. So that will get rid of the error, and that is how you use dot compare to ignore casing in a nutshell. So if they're in here, we know it's in here, and all we need to do is break. So we are going to break out of this if statement. We will then break out of our for loop because that's what the break does. And then we're going to go some code down here where we actually reassign and manipulate our values. It might be good practice to put in a return statement if we've gone through this entire for loop and there's no more values in our list, because that means that we haven't found a value. And if we don't do this, we're just going to go through some code that might make our runtime longer and make our program overall less efficient. So what we can do is have an else if statement, because we don't want to have an else statement, because this for loop can run n many times, and if we just have an else statement, if it's not found in the first n divided by 2 times, well, it's just going to return, or it will turn on the first one if our head is not the same. So we need to do an else if, and it's only if our current is equal to null. If our current is equal to null, that means we've gone through the entire list, and all we're going to do is return. If you highlight over this, in mine, it says that it's dead code, but I think that it will help our program. So what I'm going to do is add suppress warnings up here. That is going to be our entire for loop, and now we can start writing the rest of our code. So we've gone through our list, we know that it's somewhere in our list. What we're going to need to do is go through our list again. So we've gone through our for loop. We've either done the if statement and we know it's in here, or we've broken out and returned back to our main method if it's not there. So now let's just say it's in here, and if it is in here, we are going to want to delete it. So there's 3 different cases. There's one case where if it's the head, and if it's just the head, we're going to have to point our head to a new value, and we can just do this on the very first instance because it's the very first node. Otherwise, we're going to have to iterate through our list for the other 2 different possibilities. It could be either the tail or somewhere in the list. For both of these, we're going to have to iterate all the way through. So since these are 2 different scenarios, we can use an else if statement or an if else statement. So I'm going to make our if first. And what we're going to do in the if is we're going to compare the name to the head right here. So we're going to do if name dot compare to, just like always, and we'll do compare to, ignore case, just for case wise. And then inside of here, we are going to write in the head because we are comparing it to the head. And if name is equal to our head, that means it has to be equal to 0 because that is the value, the integer that it's going to output. We need to make sure that this is a string, so for instead of head, we're going to do head dot get data. And now we can be inside of our if statement. So what we want to do is we want to remove our head, and we can show this here. This value is going to have to be the new head. So before we assign the new head, what we're going to want to do is we want to kind of get rid of this. Well, to get rid of this, what we're going to have to do is we are going to get this value and then set the previous through here to null. And the previous is going to be this. What we're going to have to do is make a temporary node so that we don't lose our head. We're going to do node, and I will call this temp. I'm going to set this equal to the head. That way we can set it equal to the head. That way we don't lose the head when we go through this. So now temp is equal to head. So that means temp is going to be pointing here. Well, what we're going to do is we want to point to this next value. And if we do this, it's going to completely get rid of this from the temporary node that we've created, but not yet the head. Because if we do that to the head, we will mess up our doubly linked list. So after we've made this right here, we're going to do this outside of our if statement. That way we can actually also use this in our else statement if it's not an if. So node temp is equal to head, and then we are going to do temp dot get next. So we are going to get the next node, which is going to be here. Currently head is pointing to here. Now we are going to get here. So temp dot get next, we get that value, and then we want to do dot set prev. So we're looking with this get next right here, we're looking at this value, and then we are going to set the next value. So now we're going to need to pass in something here. What we need to pass in is what we're going to set it to. And what we're going to set it to is null. So we will pass in null like this. And that means this previous value is now null, and we've broken off the link here. Lastly, we need to make this head not point to here, but point to here. So what we're going to do is head is equal to head dot get next. That way it will get the next value and everything looks good. We don't have to reassign the tail. Since if there's just 2 nodes right here, the tail would still be pointing to here. And if there was just 1 node right here, well, we would be deleting the only node, so the tail would go along with it. And that's kind of the theory behind that. So back into here, we can code it in our if statement. Well, actually before our if statement, like I said, we need to make our new node. I'll call it node temp. It's going to be node temp is equal to head. And then inside of here is where we are going to code what we wrote down a second ago. So we want to have our temp dot and then get next, so we get the next value. And then we're going to want to set the previous value, so dot set prev. And then inside of here, we're going to pass in null. After this, we're going to do head is equal to head dot get next. That way, our head is pointing to the next value. So that's going to be that for our if statement. If the tail or middle of our list needs to be removed, we are going to go into this else statement. And in this else statement, we are going to need to iterate through our list. And we are going to do this until we hit that value. If the value is at the tail, well, we're just going to manipulate it a certain way. If it's in the middle of the list, though, we are going to have to do some more manipulation to actually get the nodes to link to each other. So inside of our else statement, we are going to have the for loop that will iterate through the list. And so we are going to have for. We're going to use this node right here, this temp node that we made, and go through this. So we're just going to have our semicolon right here because we've already created it. We're going to do name dot compare to ignore casing. And then inside of here, also it's important you do to ignore the casing because first name might be lowercase or it might be uppercase. As we see with the gem right here, it's lowercase when we're asked to delete it, but it is uppercase here. So name dot compare to ignore case. And then inside of here, we're going to see if the next value does not equal it. So the next value would be temp dot get data. As long as the name that we are trying to delete does not equal this value, we are going to go through here. Once it equals that value, we are going to break out because we found that value and we need to manipulate around it. So we're just going to have does not equal to 0. Next thing that we're going to do is just iterate the temp every single time we run through this. So we're going to do temp is equal to temp dot get next. And then that is going to be our for loop. Remember, it's just an iterator, so we're not going to have anything inside of it. We're going to have two cases. One, if it's in the middle somewhere, or second, if it's the tail. So if it's the tail, what we're going to have to do is make an if statement. What we're going to do is say that if our temporary value dot get next is equal to null, we are going to be inside of here. That means we're at the tail. And if we're at the tail, our next value is null. So we'll go back in here. We're going to look at this and we're going to say that this is the value that we want to delete. This is our current value. So what we are going to want to do is delete this. So we can reassign the tail and then we can say that the next thing after a tail is null. So I'm going to now do this in blue. So we want to point the tail over here. So we are going to do tail is equal to tail dot get prev. That way it gets the previous value. And after we do this, we are going to make our tail right here null. So we are going to say tail dot set next because tail is now this value and this is going to be the next value, but we want to get rid of this. Tail dot set next, we're going to pass in a parameter and this parameter is going to be null. So that is how we would reassign the tail. Going back into our code, we're just going to do what we wrote here. So tail is equal to tail dot get prev, previous value, and then tail dot set next is equal, or we're passing in null. Just bring back the instructions again just for reference. That is our if statement. Otherwise, it's going to be somewhere in the middle. And if it's somewhere in the middle, it's going to be a little bit more complicated. So we're going to have this else statement and it's for if in the middle. So we'll bring back one note, but we're going to need to make a new drawing because this one's getting kind of crowded. So if it's somewhere in the middle, that means that we are going to have some value or some node in front of it. We're going to have the actual node itself, and then we are going to have some node behind it, again because it's in the middle. And so we know that linked lists have a linkage here, but our doubly linked list, which is what we're dealing with, has something that points back to the previous one. We are going to have the current one that we were dealing with, we are going to have the next one that we're dealing with, and we're going to have the previous one that we're dealing with. To deal with this, what we're going to want to essentially do is get rid of these, and then we're going to get rid of this current, and then point this previous to this next, and then point the next to the previous. Now that we know that, let's actually code it inside of OneNote. So what we're going to want to do is we can do these either the previous or the next one first. I'm just going to do the previous one first. So we're looking at current. That's what we're looking at. I'm going to do these in red. The first thing that we're going to want to do is get the previous, this one right here. We're going to look at the previous and set the next value. So the next value will be this. We are going to set it to the next value right here, current dot next. So to do this, I'm going to do current because we're looking at current. Now we're going to do dot get prev because we want to look at the previous one here. That's going to be the first step. And then after this, we want to set our next value. So we're going to do dot set next. And then we are going to be setting current dot get next because we want the next value. So set next current dot get next. And this should also be a parameter. I'm losing my parentheses, but this is just a rough idea. So when we get the previous one and then we set the next value, we break this link right here, and then we are assigning this to here. That means this link is also broken as well. So that is the first part done. Now we're going to need to do the bottom part. So we're going to do the same thing, but with next. Current dot get next. So now we are looking at the next, and we're going to set the previous because we're going to want to come back this way. When we set the previous, we're breaking this link. So we're going to do dot set prev, and then we're going to pass in current dot get prev. So it gets the previous value. And that will break this link and make this point to here. And that means that our current has been killed because there's nothing pointing to it. And Java's automatic garbage collection will come and pick him up and dispose of him. So going back into Eclipse, we've named our node temp. In the example, we used current, so we're just going to interchange those two words. We'll have temp dot get prev because we want to get the previous value. We're going to set it, so dot set, and we want to set the next. And in setting our next, we're going to set it to temp dot get, and that is that line done. Now we want to do the same thing for the next value, temp dot get next, and we want to set the previous, so we're going to do dot set prev. And then what we're going to be setting is temp dot get prev. So this is the code if it is in the middle. And so this should be our entire delete method. We can see that we've gone through it here. And now that we've done our delete, we know how to delete here. We can minimize this, and we're going to go on to the inserting method where we actually insert something inside of our list instead of deleting it.